Um, so I think the main problem for this, proliferation of English slums is because they just didn't have the infrastructure. This was the first time this had happened. Most of the population were agricultural, living, working on farms. Now that they were able to move into cities, the cities were, to work at factories that were powered by steam. They were absolutely not prepared for this great influx of the population into cities, and so there were extremely poor living conditions. Eventually, a middle class emerged, and the overall standard of living of all classes was raised due to mass production of goods. With the increased production of goods, of course, there was an increase in the need for printed materials to advertise these goods. So in the early part of the century, the efficiency of steam-powered engine was applied to the field of printing, of course, right? So here we have an engraving of a steam-powered printing press, 1814. In the field of printing, mechanical innovations were speeding up the field. In 1814, two steam presses, which printed 1,100 sheets per hour, were built by Frederick Koenig, that's Koenig, for the Times of London. Before that, on a hand-operated press, only 250 sheets per hour was considered fast. The steam press increased the rate of production of a newspaper by over 400%. By 1851, presses ran over 25,000 sheets per hour. This was the beginning of making inking rollers and curved plates, which also sped up production. And a new career path here. This period as well ushered in the beginning of illustration as an industry. And here we have an example by Paul Gavarni, who was a French lithographer and illustrator, and whose work is enjoyable for its polished wit, keen observation, and the panorama that it presents of the life of his time. So here you see one of his illustrations. It's called A Bill Poster at Work, 1845. Enhanced by his deeper insight into human nature, Gavarni's compositions of this time ironically depict the grotesque sides of family life as well, and generally bear the stamp of a bitter philosophy. In 1847, he went to London, and he spent his time in England, observing the life of the poor and producing some of his most compelling work. One of the most clever caricaturists of any age, Gavarni's draftsmanship was without equal. And again, this was, the beginning of illustration as an industry. Up to this point, artists were never credited for their work. And usually it was always the printer at a print shop who was credited with creativity. And here we can see a number of, overlapping and crowded posters and bills. To serve the needs of this growing industrial power, advertising was demanding more unusual display faces, as they were called, for use on posters, stationery, catalogs, labels, and other necessities of a manufacturing and marketing economy. Because of the increase of printed matter, posters had to scream out their messages in a crowded visual environment, as you can see here, posted, up along the sides of buildings, everyone vying for attention. The classic typefaces, designed for reading books thus far, were not suitable for shouting about a merchant's wares. Soon fancy fonts became the norm in advertising, and large typefaces, in many instances 2 inches and 3 inches tall, cut from wood, were required for the increased size of headlines. Sans serif typefaces were often incorporated into posters because they were thick and heavy and added blackness to the page, calling attention to the message. So here's an example of one such early fancy typeface. With mechanization and major innovations in printing technology, example, the steam press, 1814, advertisers in particular were looking for a type that stood out from the crowd, a type that shouted, "Look at me." Thus was born the display face. So here's an example of a fat face type designed by Robert Thorne in 1821. And this is a display face specifically designed for headlines, large headlines. And this type is used for, of course, short bursts of copy, not text. And this first fat face, designed by Robert Thorne, who was also responsible for coining the term Egyptian to describe what is generally known today as the slab serif. A fat face type style such as this is a Roman face whose contrast and weight have been increased drastically with the thickness of heavy strokes. Okay, and we'll be looking at a variation of fat face a little longer here as we go along. So here we have an example of the Egyptian typeface, also known as slab serif. So in the early 1800s, with this birth of the slab serif, otherwise known as Egyptian, bracketing, which made it distinctive because it had, instead of a curved transition from the stroke to the serif, it had like an abrupt angle. So bracketing refers to the curved transition, and I guess because they needed these letter styles to really stand out, they had these very abrupt angles. So what is the name with Egyptian? You may be wondering, why is it called Egyptian? Well, upon Napoleon's return from a 3-year Egyptian expedition, Egypt was all the rage. And it appears that type founders simply used a term that was on everyone's lips, a term that was in vogue at the time. The nomenclature has absolutely nothing to do with Egyptian hieroglyphics, because there's absolutely no such thing as Egyptian slab serifs. So like the Industrial Revolution, the slab serif was born in Britain and was no doubt inspired by a new wave of advertising and those beefy letter forms that could be found on just about every billboard, pamphlet, and poster of the day. Until this time, type was designed to serve basically one purpose. It was designed for long stretches of text in books. Okay, so in this example, we see a typeface called Antique, and the antiques convey a bold mechanical feel with even weight throughout the letters. And in the upper right, typeface designed by Vincent Figgins. This is 2 lines pica, Antique, 1815. And the inspiration for the slab serif form is unknown. And by the way, 2 lines pica refers to a measure of about 40 points. And in the upper, in the upper right, we have a letter form by Robert Thorne. This is also Egyptian, and it has a significant difference compared with Figgins' designs in that there are radically modified weights and serifs. And then in the lower, and these are all variations of antique Egyptian typefaces, slab serif. And in the lower center, Robert Beasley And his design was based on early Clarendon in 1845. And Clarendon styles were wildly popular, which accounts for numerous imitations and piracies. Kind of like today. So there's always imitations. And an ornamental style of Egyptian is this Tuscan. The top two specimens are typical Tuscan styles with ornamental serifs. They demonstrate the diversity of expanded and condensed widths produced by 19th century designers. And the bottom is an antique Tuscan with curved and slightly pointed slab serifs. And as a remarkable sort of design with all of these is the fact that care was given to the design of the negative shapes surrounding all the letters, as well as the positive. So that was just as important. And here, by Vincent Figgins in 1815, 5 lines pica in shade. So now they've taken a fat face and they've given it shading. This was the first 3D, and they were the fat faces. Perhaps designers were seeking to compensate for the lightness of those initial thin strokes, which tended to reduce the legibility of fat face at a distance. So that's why they have designed the shade. Figgins began to show styles that projected the illusion of 3 dimensions that appeared bulky rather than 2-dimensional signs. These type founders varied the depth of shading, producing all types from pencil-thin shadows to deep perspectives. And all of these including outlines, reversing, expanding, and condensing, which could multiply each typeface into a kaleidoscope of variations, and foundries proliferated fonts with boundless enthusiasm. And 5 lines in this instance indicates a display type that was about 70 points in size. And William Thorogood was another designer who reversed the Egyptian italic in 1828. And here's an example of 6-line reversed Egyptian italic. The reverse types that appeared white against a printed black background enjoyed a brief popularity during the middle decades of the 19th century, and then they went out of fashion. And then more examples of 3D. So English type founders were trying to invent every type of possible design by modifying forms or proportions and applying all types of manner of decoration to their alphabets. Mechanization during the Industrial Revolution made the application of decoration more economical and efficient, and also designers of furniture, household objects, and even typefaces applied all this design intricacy to stand out. And then in 1832, Vincent Figgins coined the term sans serif. So he is credited with the design of the first slab serif or Egyptian typeface that he had released under the name Antique, remember, in 1815. And he dubbed his specimen sans serif in recognition of the font's most apparent feature, and the name stuck. It closely resembled an Egyptian face with the serifs removed. His most influential typeface was Monotype Ionic. So Great Primer sans serif, or the Monotype Ionic, created in 1821, which became widely used for body text by the newspaper industry. It was the model for many 20th century newspaper typefaces. And 2 lines indicates a display type of about 30 points. And then, because of the need for larger and larger headlines for posters, wood type was invented in the 19th century. And here are some examples of wood type posters. Posters were popular at this time for advertising. They were the mass media of the era. Clients ranging from traveling circuses to clothing stores and the new railroads led to poster houses specializing in letterpress display material. The design of handbills, wood-type posters, and broadsheets at the poster house did not involve a graphic designer in the 20th century sense, not yet. So what they had was a compositor who would sit down and compose on the fly using whatever was available in his type cases. As the size of type increased for visual impact on posters, the weight and cost of lead type became too expensive and was difficult to cast at larger sizes. So in 1827, an American named Darius Wells produced large hand-cut wooden type. Wood type made the production of large-scale type less costly and was lighter to handle on the press. Wood type meant there was no limit to the size of the type that could be printed, and the larger the better. So frequently posters were printed in condensed and extended faces so that all the lines were of equal length. Okay, and if you want to investigate the history of American wood type, there is a publication from 1969 called American Wood Types by Roy Kelly. Every specimen from 1828 to 1900. This book tells the complete story of wood type, beginning with the history of wood as a printing material, the development of decorated letters, and large numerals, and the invention of machinery for mass producing wood letters. The 19th century heyday of wood type is explored in great detail, including all aspects of design, manufacture, marketing, and the evolution of styles. Many related trades interacted with wood type production, so the book examines the influence of lithography, letterpress, metal plate, and wood engraving, sign painting and calligraphy, poster printing, and type founding. And now, further innovation. Here is a steam-powered cylinder press invented by Friedrich Koenig, 1814. Koenig was a German inventor, best known for this high-speed steam-powered printing press, which prints on the field of both sides of the paper at the same time, and it could print 400 sheets per hour. His first effort, produced in 1803, was designed like a hand press connected to a steam engine and had self-inking cylinders. These were wooden rollers wrapped with layers of felt and covered with leather. So whether an actual machine was constructed is not known, but it was considered too complicated and costly by German printers and investors. War with France was imminent, which would have discouraged speculation, so he decided to immigrate to the US. Before this period, printing presses were used that had been used by Baskerville and Bodoni in the 1700s were remarkably similar to the first one used by Gutenberg, if you can believe that, hadn't advanced since the 1500s. The Industrial Revolution radically altered printing. Inventors applied mechanical theory and metal parts to the hand press, culminating in producing a printing press in 1800 that was completely constructed of cast iron. So according to Phil Meggs from History of Graphic Design, by the middle of the 19th century, presses could produce 25,000 copies per hour, but each letter of every word in every book, newspaper, and magazine had to be set by hand. So even though they had speed of printing, the typesetting was still very laborious, very slow. So here we have an example of a compositor showing how he sets type letter by letter. The composing of lead type was painstakingly slow and tedious. Developments in new presses were often kept secret for fear of reprisal from workers. Fearing the sabotage that sometimes destroyed new machinery when workers felt their jobs were endangered, the Times in London printed in absolute secrecy on Koenig's newly commissioned steam-powered presses. So, all throughout history, as we've seen, when innovation, technology, makes the processes more economical, what usually happens is that there is a loss of of workers required, and so there was during this time many revolts, and they were often feared. The employers feared for damage, so they had to print in secrecy. And so the compositors here would just be setting their type, but they had no idea that steam-powered presses were being used. So this process of setting type, letter by letter, was soon to be revolutionized by a German immigrant named Ottmar Mergenthaler. And here you can see how he is demonstrating the blower linotype, which was the first line casting keyboard typesetter in 1886, July 3rd. Mergenthaler, once again, a German immigrant inventor who has been called a second Gutenberg, as Mergenthaler invented the linotype machine, which was the first device that could easily and quickly set complete lines of type for use in printing presses. He struggled for about a decade to perfect his keyboard operated machine in the office of the New York Tribune in New York. The editor of the Tribune reportedly exclaimed, "Ottmar, you've done it, a line of type." The new machine received its name from this enthusiastic reaction. So now you can see setting type is also being revolutionized. And so here is the Model 5 linotype machine. This is a line casting machine used in printing, sold by, of course, the Mergenthaler Linotype Company and related companies. It was a hot metal typesetting system that cast blocks of metal type for individual uses. Linotype became one of the mainstay methods to set type, especially small-size body text for newspapers, magazines, posters from the late 19th century to the 1980s, if you can believe it. It hadn't changed in all that time when it was invented. So in the 1980s, it was largely replaced by photo typesetting, offset lithography printing, and computer typesetting. The name of the machine comes from the fact that it produces an entire line of metal type at once, hence linotype. a significant improvement over the previous industry standard, which was manual, letter-by-letter typesetting using a composing stick and a drawer of letters, many drawers of letters. The Model 5 became the workhorse of typesetting with keyboards and matrix available in over thousands of languages. Okay. So Linotype, again, is this hot metal type composing machine that produces separate lines of typesetting known as slugs. So these, it, spits out these, you type on a keyboard, it produces molds, hot metal is poured into the molds, and these separate lines become slugs, or known as slugs. Sorry, they don't become slugs. Mergenthaler's Linotype machine could do the work of 7 or 8 hand compositors. The rapid development of the Linotype replaced thousands of highly skilled hand typesetters, like the guy I was just showing you, and strikes and violence threatened many installations. But the new technology caused an unprecedented explosion of graphic material, creating thousands of new jobs. So old jobs are out, new jobs are in. In the 1880s, the price of a newspaper plunged from 3 cents to 1 penny, while the number of pages multiplied and circulation soared. And as well, book publishing expanded rapidly, even more rapidly. The Linotype led to a surge in the production of periodicals and illustrated weeklies, including the Saturday Evening Post and Collier's, which reached audiences of millions by the turn of the century. So here you have an example of Linotype composition, and then ejecting a slug on the right. The operator, the Linotype machine operator, enters text on a 90-character keyboard. The machine assembles matrices, which are molds for the letter forms, in a line. The assembled line is then cast as a single piece called a slug of type metal in a process known as hot metal typesetting. And traditionally, there were 6 different kinds of metals that were used, namely gold, silver, copper, iron, tin, and lead. And here we have an example of a Linotype matrix. Mergenthaler's brilliant breakthrough involved the use of small brass matrices with female impressions of the letter forms, numbers, and symbols. 90 typewriter keys controlled the vertical tubes that were filled with these matrices. Okay, so each time the operator pressed a key, a matrix for that character was released. It slid down a chute, was automatically lined up with other characters in that line. And then melted lead was poured into the line of matrices to cast a slug bearing the raised line of type. And here's an example of the metal type produced by the Linotype 5 machine. Type setting machine. And then another machine came along, known as the Monotype. And this was a hot metal composing system which utilizes a composition keyboard and a metal caster to cast individual movable type characters. So instead of a type, the Monotype, of course, mono meaning one, this now cast individual letters. Probably wondering, well, why and what's the difference? The inventor, Tolbert Lanston, Lanston, another American, invented the Monotype machine in 1887, and this cast single characters from hot metal. It was a decade before this Monotype was efficient enough to put into production. So now the big difference between the two, the linotype machine cast lines, hence its name, linotype. But the drawback was that once you screw up one character within a line, the whole slug had to be discarded. The monotype machine improved this by casting individual pieces of letters instead of casting slugs, which were lines. So while the competition now between linotype and monotype was fierce, the printing industry soon realized there were strengths and weaknesses in both systems, and that the one chosen really depended on the needs of the individual printing plant, not the superiority of one machine over another. So here we have an operator at the monotype keyboard. It's known as the caster, monotype caster, casts individual letters which are assembled into lines in a fashion similar to classical movable type. This requires a more complex, high-speed, water-cooled casting mold that only requires one matrix per possible character, so only one mold. The monotype operator enters text on a monotype keyboard on which the characters are arranged in the typical QWERTY arrangement of a conventional typewriter, or, if you look, your own keyboard. But this arrangement is repeated multiple times, and thus the typesetter moves his hands from one group of keys to another to type uppercase, lowercase, small caps, italic uppercase, or italic lowercase. When the text nears the right margin, a drum on the keyboard indicates codes which are punched on the line to be justified. The tape is then taken to the monotype caster, which reads the tape, produces a column of justified type from which the text entered on the keyboard can be printed. And then here we have an example of a monotype matrix case. This is the mold. So this type casting is a technique for casting the individual letters known as sorts, used in hot metal typesetting by pouring molten lead into brass molds called matrices, such as this. Technological advances permitted machine set typography to be printed on machine manufactured paper with high-speed steam-powered printing presses. As a result, there was a global spread of words and pictures, and the age of mass communication had arrived. And quite remarkable, once again, to think that right up until 1980, when computer typesetting took over, this was the process for printing, everything, all printable materials. Quite incredible. Seems kind of barbaric now, doesn't it? But I mean, this was the system. There was a time when big typesetting houses would, send out salesmen with all their specimen books to all the, advertising design studios, and there were, these studios would have dozens and dozens of these large books of all kinds of type specimens that they could choose from, and then they would mark up all of their copy and send it by courier to these typesetting houses, and they would set the type for you and then sent back the galleys, as they were called, printed material that then could be pasted on boards in whatever layout was required. So it was quite a different process. And as you can imagine, with the invention of computer typesetting, again, many jobs were lost, but at the same time, others were created. So that was the, age of mass communication with the invention of all this metal typecasting.